All right, so let's start with the structure of this molecule right here, H2O2. This is actually hydrogen peroxide, or the thing that's in your rubbing alcohol when you get like a wound to disinfect it. So we're going to start by counting the valence electrons. If you look at your periodic table, hydrogen is box number 1. So hydrogen is going to provide 1 valence electron. Okay, and there's 2 of them, so that's going to be 2. All right, let's go to oxygen now. Oxygen is box number 1, 2, 3, 4, 5, 6. And so we have to draw 6, or sorry, write down 6 valence electrons. And there's 2 of them, so that's 12, which means we have a total of 14 valence electrons that we are working. Okay. Any questions about that part? The valence electrons, just count the boxes. All right, next we have to organize our elements together so that we have a structure. Now, this one right here has hydrogen. And if you guys remember, hydrogen goes on the outside of the molecule. So let's just keep it simple. We'll put a hydrogen here and a hydrogen on the outside, which means we'll put the oxygens in the middle. Okay, so something like that. All right, let's connect our elements together. So we're going to draw a line with the hydrogen and the oxygen. So that's 2 electrons. We're going to connect the oxygens. That's 4. And if we draw another line right here, that's 6. So we've used 6 electrons in order to draw our lines. Okay, so we have 6 shared electrons. Okay, which means we have 8 electrons that we still need to use. So far, so good? Okay, hopefully not too bad. All right, now, if you guys remember, the rule is all the elements want to have 8. Okay, but hydrogen wants to have 2 electrons. If you take a look at the hydrogens, there's a line next to it, right? Which means hydrogen already has 2, so this one is happy, and so is this one right here, because it has a line next to it, it has 2 electrons. Okay, but if you take a look at the oxygen, okay, how many electrons does the oxygen have right now? 4. It has 4. Because there's 2 lines next to it, so that's 2 and 4. Which means to get to 8, it wants to have 4 more. So we're going to draw 4 dots on it. So 1, 2, 3, and 4, which means it has 8 now. So we've used 4, so now we have 4 left. And this guy also wants 4, so we put 4 on that one. And then we've used all of our valence electrons. Okay? So in this molecule, we have 6 shared electrons, and we will have 8 lone pair electrons. Okay, and that's the structure. Okay, and so I know that maybe the organizing part is still a little bit tricky, but as we do more practice problems and you guys are exposed to more of these structures, it'll kind of make more sense. The more that you see, the more you'll be able to kind of see what the molecule looks like as you do more examples. Okay. All right. Any questions on this one? All right, so today is the last lecture of the unit. It's also the last lecture of 2024. So after this one, we're just going to be reviewing, and then I believe your test is going to be next Wednesday on the 18th. Okay, so just keep that date in mind. We'll finish the new lecture today. I'll give you guys the class period on Thursday to work on the review. It's already posted on Canvas, so after today, you should be able to do the review. And then I'll give you guys next Monday to make up any missing work. And then we'll take the test on Wednesday. Okay. All right, so let's get into the new information. So this is the last thing for the unit. Today we're going to learn about something called double and triple bonds. Okay, so if you guys take a look at these lines that we've been drawing, right? These are single lines, right? It's one line, and we said one line is 2 electrons. So the name for this kind of bond, this connection, is called a single bond. Okay, so just write the term single bond somewhere. Okay, so write single bond, and then you guys can just write that a single bond is 1 line. Okay, so 1 line, and it's 2 electrons. Something that you guys already know. 2 electrons is 1 line, and we call that a single bond. So if you take a look at the molecule that we just drew, it has 3 single bonds. Okay, there's a connection here, 1 line right there, a line there, and a line there. Okay, so a single bond is when 2 elements, they share 2 electrons, and you have 1 line in between. So that's what we learned last time. Today we're going to learn, the first thing we're going to learn is something called a double bond. And I'm sure you guys can kind of tell what a double bond is already just based on the name. A double bond is when two elements share 4 electrons, and that's when you have 2 lines in between. Okay. So for example, if you had, this is a molecule that has a double bond, you'll have 2 elements and you'll have 2 lines in between them. Yeah, just write down double bond just so you have that as a reference. It's 4 electrons being shared, and it's you draw it by drawing 2 lines in between. So single bond is 1 line, double bond is 2 lines, and there's an example for you up there if you want to see what it looks like. All right, so we're going to do an example of a molecule that has a double bond because I want to show you guys when to use a double bond versus when to use a single bond, okay? All right, so I'm going to scroll down a little bit. All right, so the molecule that we're going to draw right now is O2. Okay, so we looked at oxygen earlier in our warm-up problem, and oxygen gives you 6 valence electrons, right? And there's 2 of them. That means in this molecule, we're going to be working with 12 valence electrons, okay? So O2, we're going to have 12 valence electrons. Same thing as before, just count the boxes, and then we are going to organize the electrons inside the molecule, okay? So O2 is made out of 2 oxygens. So on your paper, let's draw 2 oxygens next to each other. All right, and we're going to connect them because, again, it's one molecule, so they need to be connected with one another. So I'm going to draw just a line in between them. Okay, now, if I draw one line, how many electrons did I use? 2. So now we have 10 that we still need to use. Everybody good with that? Okay. All right, so let's take a look at this oxygen on the left. So if you take a look at this oxygen on the left, how many electrons does it currently have? 2. It has 2, right? Because it has a line next to it. Okay, now it wants to have 8, so it wants 6 more. So it has 2, and it wants 6 in order to get to 8. Okay? All right, so let's try giving this oxygen 6 electrons. So we're going to give it 1, 2, 3, 4, 5, and 6. Okay, so if we give this guy 6 electrons, we had 10. Now we only have 4 electrons to work with. Everybody good with that? Okay. All right. The problem is, if you take a look at this oxygen right here on the right side, how many electrons does this one have right now? 2. Same thing, right? It has 2, which means it also wants 6. Okay. And you guys kind of see the problem, right? Because it wants 6, but if we give the one on the left 6 electrons, we only have 4 that we can give this oxygen. So if we give this oxygen 4 electrons, this guy is sad because it wants 6. Okay, and this is the situation we have to use something called a double bond. And so what we're going to do is, because they both want 6, but we don't have enough electrons to give it, we're going to take 2 of the electrons from this oxygen right here, and we're going to create another bond in between them like that. And which is going to be a double bond. So you're making them share more with one another in order to make sure everybody has 8 while using the electrons that you have. All right, so if we take a look at the oxygens now, let's count up the electrons. Okay, let's take a look at the oxygen on the left side. Okay, it has 4 of these lone pairs, so it has 4 lone pair electrons. And if you look, there are 2 lines. Each line is 2 electrons, so 2 is 4, so it has 4 shared electrons, which means that this oxygen has 8, and then the same thing for this one as well. So that's the situation that you're going to want to use a double bond. It's when you don't have enough electrons, and so you force them to share more with one another. Okay? That's a double bond. All right, so inside of this molecule, you guys can see that there are 2 lines, which means there are 4 shared electrons. And then for the lone pairs, there's 1, 2, 3, 4, 5, 6, 7, 8. There are 8 lone pair electrons. And that's how we get to our 12 right here. Okay, so that's a double bond. All right, any questions on that? Hopefully not too bad. Again, it's just adding 2 more electrons in between them. All right, so that's a double bond. You guys can probably guess what a triple bond is, right? Single bond is 2 electrons, double bond is 4 electrons. Well, that means a triple bond is going to be 6 electrons. Okay, so we have a triple bond, it's going to be 6 electrons, and that's when you have 3 lines in between 2 elements. Triple bond is when you have 3 lines in between 2 elements. And because people ask, there is no quadruple bond. Triple bond is the maximum amount that you can get in between. And the reason why is because electrons push each other away, so you can't fit 8 in between 2 elements. All right, so once you guys write down the definition of a triple bond, since you guys saw when to use a double bond, same concept goes for triple bond. I want you guys to try to draw N2 on your paper with the person next to you. Okay, count up the electrons for nitrogen. Let's see if you guys can draw N2 with the person next to you, and then we'll go over it in a couple minutes. Okay, so draw N2. Okay, so if you guys take a look at nitrogen on your periodic table, you should see that it has 1, 2, 3, 4, 5 valence electrons. So if you have N2, that's 5 times 2, that's going to give you 10 valence electrons to work with. Okay, there's 2 nitrogens, so we're going to put them next to each other, and we're going to connect them. And if we make one connection, that's 2 electrons, so that's going to get us to 8. Okay, now, this nitrogen on the left, it has 2, so it wants 6. So if we try to give it 6 electrons, the problem is now we only have 2 electrons to work with, and so this nitrogen right here is going to stay sad because it only has 4 electrons. So what we're going to do is we're going to take 2 of the electrons here, put it in between the nitrogens, and if we do that, this nitrogen is still sad because now it only has 6, 2 lines, and 2 dots. And so we have to force this nitrogen to share 2 more, and that's going to be what we create a triple bond. So if you take a look at the nitrogens, there are 2 dots, that's 2 electrons, 3 lines, that's 6, 2 plus 6 is 8, and that's how you make them both happy. Yeah. Yeah, because every element wants 8, right? And so if we kind of strip it down like that, it wants 6 because it only has 2 electrons next to it. Yeah, great question. What's up? Yeah, it's in that box up there. All right, any other questions? You have to do it when you don't have enough electrons, and so just try to give everyone the dots, and if you end up with no electrons, but not everyone's happy, that's when you start creating the double and triple. Yeah. Honestly, it comes with experience, so as you do more problems, you'll get more used to seeing them. Alrighty, guys, let's try number 4. Okay, I'm going to do this one with you guys, and then I'm going to have you guys try the last one on your own. Before we do that, though, let's have you guys count the valence electrons. Take about a minute. See if you guys can count the valence electrons. If you want to try drawing this on your own, go ahead. But I'm going to give you a minute to count the electrons, and then after that, we will start working on the structure together. All right, guys. So if you guys count the valence electrons, you guys should get 10. The carbons give you 4 each, so there's 2 of them, and that's 8. And then hydrogen's 1 each, so that's 2. So you should get 10 valence electrons. All right, let's start organizing our structure. So we got hydrogen, so they go on the outside. And carbon, they like to go on the inside. So let's organize it something like this. Okay, and we're going to make our first connections. Okay, so we're going to connect the hydrogen and carbon, make another one, and make another one like that. Okay, so we drew 3 lines. 3 lines is 6 electrons, so we have 4 that we still need to work with. Okay, everybody go with that so far? Okay, let's take a look at our carbons, because hydrogen, if you connect them, they're happy because they have 2 electrons. If you take a look at the carbon, how many electrons does it still need? It needs 4. Good. Okay, so this guy needs 4, and this guy also needs 4. Unfortunately, we only have 4 electrons to work with, so we can't just give it 4 because then we have nothing to give this carbon, and so that'll be unhappy. And so what we're going to do is we're going to start using the double and the triple bond. So let's start with a double bond. We're going to take 2 of the electrons. We're going to put it in between like this. This carbon is happy because it has 8, but if you look at this carbon only has 6, right? Because it has 3 lines next to it. And so here we will have to make a triple bond in between the carbons. And that's how you get everybody happy. So this structure will look something like this. Okay, so just to kind of repeat myself, we started with the connections like this. 3 lines were 6 electrons, so that's how we get from 10 to 4. Both of these guys still need 4 electrons. So what we're going to do is we're going to make a double bond. Now they have 6, and then we use 2 of them. We have 2 left, so we use the remaining 2 to make the triple. Yeah. Like right here. I mean, you could. They're mirror images, so you could have done it like, you mean like this?
No.
Uh-huh. Like with the hydrogen right here? No, because hydrogen can only have 2, remember? So if you do this, hydrogen has 2 lines, and that's 4. So hydrogen can't be happy. Yeah, hydrogen can only have 1 line next to it. Okay, good question. Yeah, once you make a connection with hydrogen, it's pretty much good to go. All right, you guys ready to try one last one? This will be the last example problem we do together this year. Okay, so let's try number 5. This is probably one of the harder ones that you will see. I will give you guys one quick tip though. Carbon is going to be in the dead center of this molecule. Okay, so everybody is going to connect to carbon. So with that being said, try that out. See if you guys can get this on your own, and then we'll go over in about 3 minutes. All right. All right. So let's go over this problem. So carbon gives you 4. Hydrogen gives you 1 each, and there's 2 of them, so 4 plus 2. And then oxygen is 6. So that means we have a total of 12 valence electrons. Okay? All right, now before we start, I told you guys carbon is going to be in the very middle. So we're going to put carbon in the middle. And so everybody is going to connect to carbon. That's what I mentioned before we started. So that means oxygen is going to connect to carbon, hydrogen is going to connect to carbon, and the other hydrogen will connect to carbon. Okay? So they'll connect something like this. If you have it like upside down or rotated, that's totally fine. Doesn't matter as long as everybody's connected to carbon. Okay? Okay, so if we draw these 3 lines, how many electrons did I use? 6, which means we have 6 left to use. All right, so let's take a look at the oxygen first. If you take a look at this oxygen, it has 2, right? Which means it wants to have 6 more. So let's just try giving it 6 electrons, okay, to make oxygen happy. Okay, what's the problem if I give oxygen 6? Exactly. Carbon is not happy because it only has 6. It wants 2 more. So what we're going to do is we're going to force this oxygen to share 2 of its electrons, and that's how you make everybody happy. That's it. Okay, so in this situation, we had to draw a double bond and 2 single bonds. So in this molecule, we have 2 singles and 1 double. Okay, so the singles are between the carbon and the hydrogens, and the double is between the carbon and the oxygen. And then in terms of how many shared and lone pair, well, we drew 4 lines, so that's going to be 8 shared. And then there are 4 dots, so that'll be 4 lone pairs. Okay, and that's it.